Hello, today we are going to discuss about an IIT JEE problem from 2003. This problem is related to atoms chapter, standard 12 physics, and here you are given the attractive potential formula for an electron in orbit whose radius is r, and you are supposed to find out the connection between the electron in the nth orbit's radius with that of the principal quantum number. So how we are going to do this problem is that, first of all, always remember, when you are given potential, we find out potential energy. After finding potential energy, these forces are conservative forces. I mean, the forces which are between the nucleus and the electrons are conservative forces. So we will derive an expression of force from potential energy, and then that force has to be equated to centripetal force mv square by r, and finally we are going to get the relationship between the radius and the principal quantum number. So let's write down the solution. So we know that the potential energy is equal to charge times the potential. So considering a single electron, we are talking about the hydrogen-like atoms, so we will consider a single electron. So Q becomes E, so potential energy becomes E times V, and V is equal to V0 ln R upon R0. Now, since these forces are conservative forces, F is equal to minus d by dr of U. So minus d by dr of the potential energy, that is E times V0 ln R upon R0, like this. So E and V0 are constants, so we are going to pull them outside. So minus E times V0, we can also write down log R upon R0 as log R minus log R0. Now log R0 is again constant, so d by dr of log R is 1 by r, and log R0 would be 0. So F is equal to minus E times V0 log R is 1 by r, whereas this differentiation will be 0. So we have actually obtained the expression for force between the electron as well as the nucleus, which need not to be Coulombian force as per this particular problem. So that is equal to minus E times V0 by r. Now this force is the force between nucleus and the electron, and this force is the one which actually provides the centripetal force. So here is the nucleus, here is suppose the electron in the nth orbit, and this is the Rn, and here this force is the force which is towards the nucleus, and that force as per this potential is this, and this force is actually acting as a centripetal force. So I am going to equate this force E times V0 by r as mv square by r, where m is the mass of the electron, r is the radius over here. So let's put it as Rn or r, one and the same thing. Okay, let's put this as Rn because here we are talking about the nth orbit. We can also write down one equation as nh upon 2 pi is equal to mvrn. This is the Bohr's postulate, second postulate. If squaring on both sides, what do we get is n square h square upon 4 pi square is equal to m square v square rn square, right? And from here we are going to find the value of v square. So v square would be equal to n square h square upon 4 pi square m square rn square, that is v square value. This v square value I am going to substitute it over here since these two are getting cancelled. So E times V0, that is equal to m multiplied by v square, that is n square h square upon 4 pi square m square Rn the whole square. So m getting cancelled. What else? Okay, this Rn square goes over this side. So Rn square is equal to n square h square upon 4 pi square m times E times of V0. We can see that everything is constant except n. So we can also write down Rn square is proportional to n square. So Rn is basically proportional to n. So here we are actually concluding our problem, and the solution is the dependency of Rn on n is they are directly proportional to one another. So summing up the problem, if you are given potential, find out potential energy, then considering the force to be conservative, find out the value of force by using this expression. This is the force which is going to provide the necessary centripetal force, so equate it with centripetal force expression. Very important step is this one, never miss it out. Second postulate of Niels Bohr, find out the value of V square, substitute it over here, and we can derive the relationship.